This is the beginning of section 2.3. It's about finding domain and range of a function. The solution of an equation in two variables consists of a set of ordered pairs. And a set of ordered pairs is called a relation. And we discussed that in section 2.2. And when a set of ordered pairs is such that no two different pairs share a common first coordinate, we have a function. And the domain is a set of all first coordinates, and the range is a set of all second coordinates. They may sound very abstract, but let's look at an example. So here's example number 1, which says find the domain and range of the function f whose graph is shown below. Well, what does the function look like? Well, it consists of ordered pairs. And that's what we're going to look at here. Okay, so let's write down the ordered pairs. Starting in quadrant number 1, we have 5, 2, and we have 2, 3. Then in the second quadrant, we have -3, 3. And in the third quadrant, we have -2, -2. And then we have one point on the vertical axis, on the y coordinate, on the y-axis, and that's 0, -3. In other words, this is not in any quadrant. And the only reason I chose to use quadrants is to have some kind of an order. We could have written them in any order, it doesn't really matter. So then what we have for the domain we have the set of numbers 5, 2, -3. So 5, 2, -3, -2, and we have 0. So that's the domain. And then for the range, we have 2 and 3, 2, 3, and we have 3 and -2. And we have -3. Let's apply what we've learned to example number 2. See, for the function f, whose graph is shown at the right, determine each of the following. Part A, the number in the range that is paired with 1 from the domain. That is, find f of 1. Again, f of 1 means when x equals 1. So let's look at that. When x equals 1, that gets us to this point, and then we go to the vertical axis, and that means we are now at y equals 2, or f of 1 equals 2. So a f of 1 equals 2. So if we draw a line at 1, and then go over to the y-axis, and there's 2. So f of 1 equals 2. Remembering that f of 1 means f when x equals 1. Then the second part is find the domain of the function. So the domain is a set of all the input values, and so all we do is we look at where the function begins, at which value for x, and where it ends on the right side. So the domain would be from -5 to 3, including the endpoints. So B would be the interval from -5 to 3. And then the C part, the numbers in the domain that are paired with 1 from the range, that is, find all x such that f of x equals 1. For the C part, again, the numbers in the domain that are paired with 1 from the range, that is, find all x such that f of x equals 1. Well, we can just use our ruler here and say, okay, when is f of x equals 1? Well, it's at this point here. And the corresponding x value is -4. So x equals -4. Or another way of saying it, f of -4 equals 1. And then the last part, the D part, asks for the range of f. So here we look for the lowest point of the function, and that's here at -1. And we look for the maximum point of the function, which is at 4. So therefore the range is from -1, including -1, to 4. So that would be the range. So -4 to -1 rather, excuse me, -1 to 4. So that would be the range. And this, by the way, was the domain. So here you have the answers. Let's look at exercise number 2. For the function f, whose graph is shown below, determine each of the following. A, the number in the range that is paired with the input 1, that is, find f of 1. So remember, this stands for find the value of the function when x equals 1. So when x equals 1, well, then the function value, we go down here, and the function value is equal to 4. So in other words, f of 1 equals -4. Now, for B, the domain of f, we're talking about all the input values, in other words, the values on the horizontal axis. And so when we look at this ordered pair here, -3, 4, so -3 is here. And this pair 3, 4 means that's positive. X equals 3 is here. So then the answer for the domain would be the set of all x such that x is less than or equal to 3 and greater than or equal to -3. Or in interval notation, we could write it as -3, 3 for the domain of the function. And the C part, the numbers in the domain that are paired with 4. Well, the numbers paired with 4 is 3, and the other number is -3. So then the numbers paired in the domain, the numbers in the domain that are paired with 4 would be minus 3, comma 3. And then the range of f, in other words, the set of all the output values, are from minus 5 to 4. So in other words, the set of all y such that y is less than or equal to 4 and greater than or equal to minus 5. That's in set notation, and in interval notation it would be from minus 5 to positive 4. That would be the range of f. So here we have all the functions. The function at 1 is equal to minus 4. In other words, the value of the function is minus 4 when x equals 1. Then the domain would be between x equals minus 3 and x equals plus 3, indicated by the set of all x such that x is less than or equal to 3 and greater than or equal to minus 3. Or if you write it in interval notation, minus 3, comma 3. And remember, we have brackets here because the endpoints are included, indicated by less than or equal or greater than or equal. The numbers in the domain that are paired with 4. If you look at that, here there's a minus 3 is paired with 4, and there's a plus 3 paired with 4. So the numbers paired with 4 are minus 3 and 3. And then the range of the function is from minus 5 all the way up to 4. So we can write it in interval notation, the set of all y such that y is less than or equal to 4 and greater than or equal to minus 5. And in interval notation, it's from minus 5 to 4. Again, brackets, because the endpoints are included. In exercise 3, we are asked to find the domain and the range of the function f, whose graph is shown below. And when you look at this graph of the function, you notice that it continues, down in the downward direction here. That's where the arrow points. Whereas in contrast to the other example, here it ended. It has endpoints. So that is why we can say that as far as the domain is concerned, in other words, the x values, that could be any x value. So the domain, all real numbers, or we could write an interval notation from minus infinity to infinity for the x values. Now, for the range, the highest point of the function is at 4, so that's the set of all y, excuse me, the set of all y such that y is less than or equal to 4, because it goes down to minus infinity. Or in interval notation, we could write that as minus infinity to 4 with a bracket. Here's the value of 4 for the function. In the next exercise, we are asked to find the domain and the range of the function f, whose graph is shown below. And so here, for the domain, there could be any x value. Remember, the arrows mean that the line continues without bound in each direction. So the domain is a set of all real numbers, and the range along the y-axis, it's the same. It could be any number, so the range, all real numbers as well. Similarly, when we have the next exercise, find the domain and the range of the function f, whose graph is shown below. So the domain has really no restrictions. Any x will give you corresponding y value. So all real numbers. And the range, in other words, the values along the y-axis, it's the same, all real numbers. For the next exercise, 5, f of x equals x to the third minus absolute value of x. There are really no restrictions on any of the values of x. So we can say that the domain is all real numbers. In this exercise, we are supposed to find the domain of this function here. And it looks like we could make x any value, because even 0 means that's 4 divided by 2. But let's look at this. The best way to find out about what the restrictions are on the domain is to ask ourselves, for which values of x is the denominator equal to 0? And the reason why that's pertinent is because 4 divided by 0 is an undefined expression. So we have to exclude any values of x that would cause the denominator equal to 0. And the way we do that is we take the denominator, set it equal to 0, and solve for x. So we have done this before. So the denominator is 3x plus 2. And we set that equal to 0, and then we solve this little equation for x, as we have done many times. We subtract 2 on both sides, so we get 3x equals negative 2. And now we divide both sides by 3 to isolate x, so we get x equals minus 2/3. Therefore, or thus, minus 2/3 is not in the domain of f of x. All other real numbers are. In other words, when you replace x with minus 2/3, we can just do it here on the side and see what happens. So if we calculate f of minus 2/3, that means we replace x with minus 2/3, we get 4 divided by 3 times minus 2/3 plus 2, and that is equal to 4 divided by, so the 3's cancel, we just get a minus 2 from this term here, and then a plus 2, and then we get 4, and since minus 2 plus 2 is 0, and again that's undefined. So the function would not even be defined at that point. So that's why we have to exclude that point. So therefore, we conclude that the domain is a set of all x such that x is a real number and x is not equal to minus 2/3. And so the way we indicate, so that's in set notation. And the way we indicate that in interval notation is we take the set of numbers from minus infinity to minus 2/3, union the sets of minus 2/3 to positive infinity. Now notice we have parentheses here. So in other words, minus 2/3 is not included in any of these sets of numbers. to the left and to the right of minus 2/3. So in other words, we can come arbitrarily close to minus 2/3, but not equal minus 2/3, because then we know what happened. I just show you what happens then. You get an undefined expression, and that's something that we can't have. Very important example. I hope you get the essence of it, and there are similar examples in the book, so I hope you study those as well. So we conclude this section by doing a little review on functions. So this is a review of functions, the function concepts considered in these last two sections. So here's a graph of a function. Again, the formula for the function in this particular example is x squared minus 7. That's the graph of the function. Here it is, f of x equals x squared minus 7. And for every input of f, there's an exactly one output. One input, if it's x equals 3, we get one output. For every input of minus 1, we get a certain function value, one output. When 1 is the output, the input rather, minus 6 is the output. Here's the example. 1 minus 6. It's on the graph. So we can say that f of 1 is equal to minus 6. The value of the function is minus 6 when x equals 1. And again, the ordered pair 1, minus 6 is on the graph. And the domain is a set of all inputs, and that's a set of all real numbers. It can range from 0 to positive infinity, and from 0 to minus infinity on the left. So that's a set of all real numbers, that's the domain. And the range, that's a set of corresponding y values, and it starts at minus 7, and then it grows without bound. So we can say the range is a set of all outputs, the set of y, such that y is greater than or equal to negative 7, or in interval notation, minus 7 with a bracket, comma, infinity with a parenthesis. As you know, infinity always gets a parenthesis. So here's a quick review of all the concepts we've talked about, neatly summarized here. And I hope they make sense to you and that you do the additional exercises to get a good working knowledge of the concept of a function. And this concludes section 2.3.